Okay, so to start chapter 2, we're going to use completing the square to write the quadratic in vertex form. So to start, you have to make sure a is equal to 1, which in this case it's 3. So in order to make it 1, you have to divide the entire equation by 3. And once you're there, you'll end up here with x squared plus 2 over 3x plus 1/3. The next step is you move 1/3 to the other side, and you're finding a new c, and to find that you use this, which is c equals b over 2 squared. And so once you do that, you'll end up with 1/9, and you can't forget to add to both sides. And so now you should be at x squared plus 2/3 x plus 1/9 equals 4 over 9 here. So the next step is to factor this. So you'll end up getting x plus 1/3 squared equals 4 over 9. You can then, to isolate x, you can take the square root of that, of both sides, and you'll end up with x plus 1/3 equals 2 over 3. And finally, you'll get, once you subtract 1/3 on both sides, you'll get x equals 1/3 to finish that. Okay, for the next one, we are writing an equation for the quadratic function whose graph contains the given vertex and point. So basically, in this one, you're taking vertex form, which is right here, and you're inputting these values. And once you've done that, you'll get this, and you're basically simplifying until you get your answer, which is a. So the vertex is going to be hk, so -2 is h here, and -5 is k, which goes here, and then this is just your x and y values, which go y and x. So you're just doing simple math until you get your answer. Okay, for number 8, we are writing an equation for the linear function satisfying the given conditions. So they give us the f of 6 equals 3 and f of -4 equals 5. That's basically giving you just an ordered pair, or just a set of x and y values. So the same thing for -4 and 5. So the 6 is the x, and the 3 is the y, so it's input-output. And you're basically going to take those values and input them into this slope form, the y2 minus y1, so 5 minus 3, and then x2 minus x1, -4 minus 6, and you're going to end up with -1 over 5. Okay, so once you have your slope, which is -1 over 5, you have to input that into point slope form, which is y minus y1 equals m times quantity of x minus x1 squared. So I used the first one in this case, or the first set of values in this case, so I ended up with y minus 3 equals -1 over 5 times quantity of x minus 6 squared. And the only step for this to get into standard form is you add the 3 to both sides. Okay, so for number 9, we are writing the complex number in standard form, and the number we're using is root 2 over 2 plus root 2 over 2i to the 8th power. So right here I just kind of showed them all out, because that's essentially what you're doing, is multiplying it 8 times. So the first thing you want to do is distribute. So right here is, I multiplied 2 of them together, and I ended with 2 over 4 plus 2 over 4i plus 2 over 4i plus 2 over 4i squared. And I squared is equal to -1, so when you multiply that by 2 over 4, you're going to get a -2 over 4, so I have 2 over 4 minus 2 over 4 plus 4 over 4i, and that's going to, these are going to cancel, and that's going to end up giving me 4 over 4i, so 1i. Alright, so now that we know that root 2 over 2 plus root 2 over 2i squared is equal to I, we know that root 2 over 2 plus root 2 over 2i to the 8th is going to be equal to I to the 4th. And because I to the I squared is -1, I to the 4th is going to be +1 for your answer. For number 10, we are finding the cubic function in standard form with the given table of values. So to start, you're looking for an x value that has a y value that is anything but 0. So in this case, it's 4 and 16. So you can single those out and use the others, which are 3, 5, and 6, to make an equation here. So we have f of x equals a times x minus 3 times x minus 5 times x minus 6. And once you have that base equation down, you can input this, or these values. So for all the x's, it's 4, and the y, it's 16. So you get 16 equals a times 4 minus 3 times 4 minus 5 times 4 minus 6, which is then gives you that, which then eventually gives you a equals 8. So once you have your a value, you can go back to your base equation and plug it in and distribute it. So you'll get the 8x minus 24 times x minus 5 times x minus 6. And from there you can continue to combine these two to make it easier. So you'll get x squared minus 11x plus 30. And then you can combine that to get this large quadratic of 8x cubed minus 332x squared plus 504x minus 720. Okay, for finding the exact solution algebraically, we are starting with 10e to the 0.045x power equals 120. So the first step is to divide 10 on both sides. And once you've done that, you'll get e to the 0.045x power equals 12. And in order to get rid of the e, you can take the natural log of both sides, and that will then get you 0.045x equals 2.48. And from there you can just divide and simplify, and you will end up with x is approximately 55.11. And for number 14, we're doing the same thing as 13. We are finding the exact solution algebraically. So to start, you subtract 4 on both sides, so you end up with negative log of x plus 3 equals 3. And then you can quickly get rid of the negative by dividing it on both sides. So you'll end up with log of x plus 3 equals negative 3. You can then convert that into exponential form, and you'll end up with 10 to the negative 3 equals x plus 3. And 10 to the negative 3 is equivalent to 1 over 1,000. So you have that, or 1 over 1,000 equals x plus 3. Then from there you can just subtract 3 on both sides, and you will get negative 2,999 over 1,000.